Okay. All right. Hi everyone. Thanks for joining us again. This time, I have a question for Sean. So, Sean, I want you to. Uh, so, so I want you to write a method to return all subsets of a set.
Okay. Are these uh can I assume integers for or
Yeah,
strings for the subset?
integers.
Integers? Okay. And input is a array and I want to return an array of arrays.
Yes.
Okay.
Actually, I'm gonna say so to make this easier, I'm gonna say an array list of
Okay.
array lists so that you don't have
Uh,
to worry about the uh, expanding and expanding the array. So you
okay.
can just
Yeah.
focus on adding.
Okay. Um let's see.
Or array lists of array lists.
Yeah.
But that's
I was going to ask that. Um think of other questions to ask. I think that's all right. Okay, so I'm gonna go into example. If my ints are so if we're when we define subsets of a set,
uh-huh.
does that mean a permutation of the integers or a combination of the integers?
So for example, if I had a set with
So I have like one, two, three.
yeah, okay, so if
Do I
it's one,
care
two,
about what order? I guess these are in.
the order doesn't matter.
Does not matter. Okay, so this is a combination.
Yeah. So for let's work this example out by hand.
Okay,
So
sure.
yeah.
So based on the combination definition, uh, your subsets are one, two.
Hmm.
Let's do one, two, three. One, two, one, three,
Yep.
two, three, and one, two, three, and that's
And
it.
there's nope. There's one more.
Uh,
The empty.
the empty set. Okay, okay, okay. So let me write down. All right. So for a more I guess more complete example, let me just add one more.
Hmm.
So one, two, three, four. It'd be one, two, two, three, one, two, one, three, one, four, two, three, two, four, and three, four. One, two, three, two, three, four. Um, okay. I think it's better if I write it like all in one line,
Hmm.
so this is more clear. So I have 1, 2, 3, 4. 1, 2, 1, 3, 1, 4. 2, 3, 2, 4, and then 3, 4. I have 1, 2, 3, 2, 3, 4, and an empty set. And 1, 2, 3, 4. Okay, so these should be all the subsets that I'll be returning.
I think you're actually.
I'm missing 1, 1, 2,
Let's see.
3.
Yeah, you're missing
1, 1,
You're dead.
3, 4.
That, and you're also still. There's one more.
1, 2, 4, right? Okay. Alright.
So actually, why don't you try a smaller example?
Sure.
Or actually try the smallest example first. Let's see if we can build on that.
So I guess the smallest valid example would just be 1. And
Sure.
nothing.
Yeah.
And that'd just be nothing. If you have one element, is nothing at 1. And I'll do it for 2. Okay, so I do see a pattern here now. So if I did, I guess 1, 2, 3. 1, 2, 2, 3. Okay, so I guess a subset for empty one is just empty. A 1 includes the empty one plus a 1. A 1, 2 includes the 1 plus the 2 and the 1, 2. So each time we add a member to a subset starting from empty, we're appending more values, and this and this and that. And for this, it would be itself, all the things that have, I guess, all the numbers that include the new member. Okay. Okay. So I guess I'm trying to find that pattern where we add a new member to.
So
I could also break. So I guess for 1, 2, I know that there's a 1 which is defined here, but that's a combination of a 2 as well.
Okay, so
in here,
for the subsets of 1, 2, 3, why don't you? And you notice that half of them have the number 3 and
Mm-hmm.
half of them don't, right?
Right.
So why don't you list them out in 2 lines, one with 3 and one without 3,
Sure.
and see if you can find a pattern.
You mean okay.
So yeah,
Uh,
just
um, okay, so it is the valid sets of these plus a 3.
mhm.
So it is always the case that it doubles.
Mhm.
Is that true? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Seems to hold up.
So what's
Okay. So it is the set before, but you add a 3 to it.
mhm.
I guess this is like a plus 3 kind of relationship.
Yep.
Okay. I think that makes things easier. Okay, so the pattern here is if I were to do like a tiny recursion with these two. Oh, sorry. Give me a second. Sorry.
Yep.
Hey, how you doing? I'm Rick. You were fast passengers in the 69? Oh, that's fine. That's fine. Don't worry about that. Because what they're doing is they're climbing up the back. Now you're getting in through the back. So, and you're trying to do it. See how they're actually getting in. I want to sorry, guys. Don't go. Do what you got to do and unlock the door and the second thing that I think. Thank you.
Hey, sorry about the interruption. All right.
All right.
Yeah. So we have mice in our house, and we've got an exterminator come check it out.
Okay.
Yeah. Okay. So if I were to do like a simple, I guess, simple function that just uses these two examples, um, the recursive element in this would be you pass you take the subset of the empty subset and you just add a 1 to it. And if it's empty, empty would be the base case here.
Mhm.
And when you return the base case, you append a 1 to all the things. I guess you double the array. You append 1 to it. So let me just write that down. Like, base case is empty set. Take the returned recursion and take the return recursion and I don't know, like double it maybe? and then add one to the double. And think of other ways to think about this.
So by double it, you mean making a copy of it?
Yes. Yes. Well, this, yeah, I'm not sure if this is the correct way to think about this recursion, because we're passing it from,
So
well,
let's say
passing the whole figure.
You're taking all the subsets of 1, right? So
Mhm.
what's the general pattern here? Like
So we have, for 1, we return a
or how about
so okay, I think we can like chop off the last character
mhm,
in the array and then recurs that.
mhm.
So if I chop this off, this will be, when I recurse it will be empty. It will see that it's an empty and return it. And with the returned empty array on the previous call, we double it and then we add 1 to it. Add 1 to the one of the new elements.
So I
Is that
think you need to explain that a little bit more clearly.
okay? So when we take off one character for a 1 input, it will be empty, and a return empty because that's the base case. But now we want another. We still want this 1 in there somehow, right?
Mhm. Actually, I think what might help is you see the 1
Mm-hmm.
and 1, 2. Draw squigglies around those as well. Yeah, so, and then also the 1 on top. Yeah. So use. Does that help?
You add itself to it. Yeah, so you can, yeah, you can add itself to it. But if I move on to the 1, 2, 1, 2 is itself here.
Okay.
I do, but I also need to add the 2.
So
Yeah, which is why I'm like kind of getting tripped up here.
so here in that 1, 2 example,
Mm-hmm.
I'm gonna ask. So you see the first and the third element.
Yep,
Yeah.
the empty and the 1, 2.
And the one with and the 1 with 2.
This one?
Yeah. So what? So how are they different? What's the difference?
Uh,
Or
between.
how would you transform from the empty set to that set?
From the empty set to this set?
To the one with 2. Yeah, this one.
I
And
would
empty.
pop into itself as well.
Right.
as
Okay.
a member by itself.
And what about 1 and 1, 2? What's the difference there?
Okay, it one is this. 1, 2 would add this. You can do 2.
So
So you can.
so what
No, go ahead. Uh, hmm,
half of them have 2, right? And half of them don't have 2.
right.
Do you see a way that, you know,
Right, so we double this
mhm.
and then add, just stick a 2 in each of the duplicates.
Yeah.
Okay, so that essentially is this.
Hmm.
Is that enough for me to get started for coding? I think so. Okay, alright, I want to jump into coding.
So actually, I wanted to say, um, I wanted you to say you're essentially making a copy of. So you're taking the subsets of the previous set without the current element.
Mm-hmm.
So you're taking that and you're making a copy of that, and then for in the copy, you're adding the current element to each
Right.
subset.
Yep.
That would be a that would make it easier.
Okay.
Yeah. So yeah, why don't we jump to coding then?
Sure.
So for I think to start you off here, I'm gonna say I want an array list of array lists
Mm-hmm.
of integers.
Array list of array list of integers. And this will be find sets. Can my input just be an array list instead of array?
Oh, yeah, it's an array list.
Okay, as well. Okay. Okay, so I'm not sure if this needs to be an object type, but well, we can change that later if it does. Make this 4. I'm feeling lucky today. Okay, so my base case here. Base case, if I find that my array list is empty. Ooh, that's interesting. How do I signify an empty array list?
I'm actually trying to get to your code share, but
Oh, does it work?
well, it's not updating.
Is it ADKOK4?
Yeah,
It's not updating?
yeah. Is it set to share?
It should share by itself.
Oh, I'm there, but it's You only got part of it. Well, anyway, why don't you keep going? I'll figure it out.
Okay. I just refreshed. Refresh your browser. Maybe that'll help.
It just refreshed by itself.
Is it good? Is it good now?
Yeah.
Okay. All right. Cool. I know we're a little bit short on time, so kind of try to go faster. My base case. Is for this purpose. Let's say. I need a way to indicate a null case. Let's just use a temporary minus 1 for the null case for now. And assume that -1 is not in our input. Empty. That would put -1 in everything. Okay.
Well, maybe one way of
It's just making base case for one member.
I think something that might make it easier for you to do is so here, instead of just passing in a list, instead of just passing in the set, you can also pass in an index.
Okay.
Yeah.
An index?
But actually, it's fine. Why don't you do it your way?
Okay. Oh man. It's empty.
Well, you would have to generate something, right?
Right.
Create something.
Yeah, perhaps an array list isn't the best way to do so. I mean, I can't imagine an array being better. Set.append. Can I append a no object to array list? If I have integer, maybe I could.
Do you need to? So think of it this way. This is saying this is a method to return all subsets of a given set, right? So if the set was empty,
then there's no subsets.
You're not returning null, though, right? You're returning an empty set. So how would you represent that?
Just return set.
But then well, set is an array list. Like your you want to return.
I see. Okay.
And actually
return.
you sure it's set? Well, yeah, sorry. Why don't you, yeah.
If the set,
No, just
I'm pretty sure it's set for
ignore
now.
that. Ignore that.
Okay, yeah. I'll double check. I'll check that later. Set, I mean, array list. If this is an empty set, and this set is empty, put in the empty set.
Yeah, that's fine. So, and now you need. So now you have to paste.
Right. So, what I want to do with recursion is chop off one character, throw that into the recursion, the new one without the last character. When I return it, I will double it, and I'll append to the new everything after the new double. So here it's like chop off one. Is there a method that I can use to get a subarray? There probably is. Of a set?
Let's say there is one.
Okay, let's just say get subarray, and then so I would do find let's say LOL means list of lists. Return equals find subsets. Let's do from 0 to set dot length minus 2, so that the length minus 2 should chop off the last character. If the length is already 1, now return -1. I don't know if I want that. Alright, anyways, I'll do get subarray without last element for now.
Okay. We're passing in set, right?
Oh yeah. Once I get my returned list, what I want to do is so let's also say I have a function called So this function doubles the list, well, gets the list of the size of the list as an index and doubles it and returns that index.
Mm.
And now we loop through from well, middle index. We need the list too. Let's get a. Let's just repopulate this, and I'll take this out. List. Middle index equals return dot length by 2. So since we're doubling it, this will always guarantee our middle index. Oops.
Or would it be simpler to just make a copy and then combine them later?
You could. That's one way to do it. Let me do it this way first.
Okay.
Yeah. Let's do turned. So this will give me a bunch of array lists. So, and then we add I to it, or we add the, I guess, subarray without last. So the element of the subarray, so that would be set, let's just say like get last. And after we do that, I think we're good to go for this return. Okay, so I'm gonna go through examples to see if this works. So I'm gonna use 1, 2, 3 as my example.
That's alright. The 1, 2, 3.
Yeah. So first, my set is 1, 2, 3. It's not empty. Well, 1, 2, 3. Set is not empty, so, and then we'll chop off the subarray without last. So we're pushing a subset of 1, 2 into the stack, and I'll go back in here. It's still not empty. We'll do the same with 1. It's still not empty, so we'll do that with like an empty set. So once the empty set goes in, it is empty. You make a new array list or list of lists. You append set new list of lists. Okay, so there's nothing on it. You append the set, which is an array list that is empty, into the list of lists. I think that makes sense, and then you return it. So once we're back here, we return this returned list of lists. This return list of list would be an array list with one member, but it's empty. So now we double it. So this will be this. Get the middle index. So for 2, it's 1. For I guess for starting to loop from 1 to the length to 2. This length is 2. Oh yeah, as well, it's less than length 2. We get 1, which is this, and then we append set.getLast. So set.getLast is 1, so we make that a 1. And then we return this. So given this, at the 1, 2 stack, we've returned this. Double this again, so this will be like that. Get the middle index, which is 4 divided by 2, so that's here, starting at 2. So from 2 to 3 indexes, we append the last element. So this would be 2, and this would be not. No, I think I'm okay. Yeah, I am not using the right convention for this. Yeah. Okay. So when I say append, where I'm missing, another set of braces in here. So in here. All right. So now we return that. We have this. We double this at 8. So start at 4, and then we append 3, which is the last character. So that'll be 3, 3, 3, and then 3. And according to our examples, we have empty 1, 2, 3, 4. Sorry, wrong set. Empty 1, 2, 3. 1, 2, 1, 2, 2, 3, 1, 3, and 1, 2, 3. So I think this is the overall algorithm of how this works.
Yeah, that seems to work. Yep.
Okay. There's ways. Should I talk about efficiency first, or ways I should optimize it?
Sure.
Okay. Well, I'll talk about the efficiency.
Tell me about the runtime.
Yeah. So. In terms of space complexity, we are kind of breaking a set of array down into empty ones. We're passing it back, and then passing it back, doubling it. So we're passing this back, doubling this, passing it back. Okay, so the space complexity is about 2. When I do return this, it's gonna be, though, it should be.
So what's the maximum number of things stored at one time?
Yeah, it's so like for 3 we have 8 elements.
Yep.
For 4 we have, for 2 we have 2 elements. For 1 we have 2. For 2 we have 4. Space complexity is 2 to the n. So let me check for 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so it is 2 to the n. And then, oops.
Time.
For time, Um, we are looping through during each recursion when we double it. We loop through, I guess 2 to the n divided by 2 to append as well. So, so that's on the scale of 2 to the n. I want to say it's, and we're doing that for each member of n, or each iteration, n times 2 to the n. So that is my time complexity here.
Good. And you wanted to say something else before.
Oh, yeah, I was thinking if we have more time, I would optimize. I would try to see where I can optimize.
Okay. Can you tell me how? Like, if
Yeah, so let's see. You did mention just making just doubling a new instance of this list, looping through that and appending it. I don't know if that's faster.
That isn't. So that isn't actually to make it to save on space or anything. That
Right.
Just
it's easier to read, I guess.
Yeah, and also to protect you against index mistakes.
Yep. Just give me a second to see. So, I guess like working with an array list. A lot of the optimizations might come here. Get subarray without last. Usually returning a completely new subarray would entail kind of copying everything over. So if that's a function that's like remove last in like constant time, I think that would be a place where you can optimize. Yeah, I don't know. Doubling it, like that's required to loop through everything, pushing it into the end.
I think you might be okay here.
Yeah. Okay. Yeah, I don't see too many places.
Yeah. So actually, you've only created one array list of array lists, right? For all of the, because the only time it gets created is when it's when it's a base case, and then every time you're still using the same one. You're just So actually, that's fine. I think it's fine.
Okay.
At least
append set. Actually, I think when I append set here, correct me if I'm wrong, but I'm using the input. So, when I append it, is it by reference, or should I need a new?
Well, actually, so at first I wasn't sure if that was okay, but actually, if you look at your code here, you're only appending it when it's empty, when set is empty. So the only time you would append it is when you're appending empty array list. Because
got it. Okay.
Because in the other cases we're
yeah. So we're assuming when we double it, we make new instances of this, and they will be independent. Okay.
Yeah.
Yep. Yeah, I think that that's it on my end.
Okay, cool. Um, yeah. So, all right. So time wise, I think
It's
we
like,
did just okay.
yeah.
So when you finished, it was about 45 minutes. But then I asked you to see if there was anything you could optimize. So I
Okay.
mean, we did well. Uh, you did a good job defining the constraints. So at first you uh, made sure you had the right definition of subsets
Mhm.
and everything else. I'm not sure. So on my end, I'm not sure if I think maybe I might have rushed you a little, but
Uh huh.
uh, I'm not sure how else I should have handled
No, I think it's good. I think if you wanted to push me to finish it, you probably would have had to rush me. Yeah.
it.
Um, I think this was a really helpful hint. This one here.
Mhm. So I wanted you to see how how you're actually just looking at the all the subsets of the previous case and adding just the current element to all of them.
Yeah. Yeah.
Like, yeah, you can see it.
Yeah. Yeah. I do think one thing I need to work on the most in terms of recursion is detecting that pattern.
So this is actually a question. I don't know what happened to my computer. Hello,
I'm still here.
hello. Okay, I can't see anything though.
Okay.
Okay, never mind. I'm back. So this is actually question 8.4. So you
Okay.
should take a look at the solution. There are actually two solutions to this. One is the recursive solution, and the other
Mhm.
one is
The iterative one.
uh, combinatorics. Combinat, yeah. So
Mhm.
that one I actually didn't really look at yet. But yeah, you might want to take a look at that and see how it compares with yours. That's all I have.
All right. All right. So wraps it up for this one. We'll see you in the next session.